Thanks, everyone. This is Pasam Nutan from the CarbonVision team. So our idea is basically about the carbon emission around the world and its side effects. Our idea like basically discuss how the carbon emission around the world can be decreased and the sustainability can be increased. So our idea uses the Tableau dashboards and the various Tableau API tools and all the things that you can see here. We have used the Python for the programming language. So let me show you the dashboards for before the ML prediction. So this is the ML Tableau. So this it is the distribution of actual CO2 values count across countries. We have used the labels here. We have used the error bin where we have used error by showing the difference between predicted and the actual values. This is the distribution of the error across all the data points. Then we have the energy per capita and the CO2 per country. So we have used this in the columns and the rows, and we have also have the trends across the countries by using the scatter plot. Then there's the basic dashboard here. So it discusses all of these things. Where we have created the relationship between GDP and actual CO2 emissions. This is the actual CO2 and this is the GDP. We have used this various bubbles for this showing the differences. And this is energy usage on the GDP. Error we have discussed already. We have shown the difference between predicted and the actual values. So this dashboard basically describes how the emissions are happening and how the sustainability can be increased. And this is a basic design. So after the prediction will be discussed by my teammates, and the other parts will be discussed by the teammates. Thank you.
Learning model that will predict the carbon dioxide emission by using the existing data. So it will help us to make real-time decisions based on the past collected data. So what we have done is we have imported all the necessary modules like pandas, numpy, sklearn, pre-processing to pre-process matrices. This ensemble this thing as random forest classifier. That's the model which we are going to use in our project. So first, what we have done is we have loaded our file. Then we have cross verified, we have debugged if the file is found or not. Then we have selected the top columns which we require in this process. Then we have done the log transformation. Then we have split the data as x and y, as y is our target. So what is our target? Our target is to predict the CO2 emission, right? So that is that is stored in the variable y. Then we have used train test split. This is a inbuilt thing which is available in sklearn. So we have used it, and then we have scaled our features. Then we have transformed it. Then we have optimized the model, and the model, as I already told, the model is random forest classification with a random state of 42. So we have all fine tuned the parameters using grid search CV. Yeah, then we have predicted. So once the prediction is done, we have added this thing to the existing file. So as you can see, this will give out a file called optimized model predictions.csv. So yeah, that's it. I mean the output will be aligned model prediction.csv, which will have the existing prediction plus the prediction which we have existing data plus the predictions which we have made in our machine learning model. Thank you. Team has made a carbon dioxide emission dashboard. Here on my left, you can see the horizontal bar chart, which says that how much carbon dioxide has been emitted by different countries over the years. We can see like there are countries like Ireland which have very less carbon dioxide emission, but other countries go really high. For example, like Europe, uh, yeah, China. So these countries, Asia. So these countries are in the top carbon dioxide emitters. So here you can see the historical trend of carbon dioxide emission. This is a scatter plot which represents it. On my next chart, I am. This is this leader and outliers. Outliers can be of two types. One can go like extremely high emitters, or they can be extremely low emitters. So this chart says about the outliers and the leaders of carbon dioxide emission, and the last chart says about the insights from different countries. For example, it says about the source of carbon dioxide emission. For example, the blue balls represent the carbon dioxide per capita by coal. I mean, the coal carbon dioxide emission per capita, and the orange ball represents the energy per capita. That's it. Thank you.
So what happens about the average, why we are calculating CO2 emission and why it's very important? Because there's drastic changes in the world which is happening right now. There's like catastrophe and there's like disasters happening around the world. There's like floods here and there. There are like wildfires. There's a lot of destruction which is due to the climate change. This climate change, this is all our carbon emission indirectly or directly affects this part, which is also the greenhouse effect or all the other climate factors, which will bring about a drastic change. So what we need to do is that we need to find a very good way to prevent it. This can be done with the help of the CO2 emissions, which are shown here right now. We can make a very good a presentation of CO2, and we can make a solution from the analysis, and we can know what to do and what not to do.